After the first exchange, ano yung number nila? Yung isa 20, yung isa 20. So magmi-meet yung dalawa. Tapos yung isa magiging what? 15. Yung isa magiging 25. Okay? And then that's 27. And this one is becoming 13. So if you're going to plot them, you will have it like this. And then this one like this. And starting here, there's no exchange or no change in the concentration already. So ganun yung trato ko in teaching my students in equilibrium. This is really hard to what we call teach a very abstract concept. Okay, so they said that equilibrium is the state in which there is no observable changes as times go by. Because what happens is you have a dynamic system. Ano ba ibig sabihin ng dynamic? I think it is in the module. Okay, so when you have a dynamic system, it's keep on changing, but it just happened that the rates of the forward and reverse reactions are equal. And the concentrations of the reactants and the products remain constant. So yan yung what we call concept of equilibrium. And you may ask yourself, okay, how common is this equilibrium? To tell you frankly, this is more common than the so-called one direction reaction. So maybe at this time, the one that you know is there's always the reactant on the left side and the product on the right side. But in fact, okay, rare lang yan. Most of the time, the system is at equilibrium. Once you form the product, it what we call react to form the reactant. So for instance, when you have acetone, okay, if you put acetone, let's say in a beaker, and then you put a big beaker on it, so what will happen? At the beginning, your acetone will evaporate, right? So from liquid, it goes to the gas phase. Now, since they are enclosed, when there are enough gases that are formed, what happens? Since they cannot escape, they remain on that thing. So those gases starts to condense until such time the rate of vaporization is the same as the rate of condensation. So that's, we could say, a physical equilibrium. Why physical? Because you maintain the same composition. Okay, so sa chemical equilibrium naman, the example that I can give you is this one, wherein you have the nitrogen tetraoxide producing 2 nitrogen dioxide. So after some time, this is the brown gas. Okay, so when there's enough brown gases that form, okay, it will combine itself to form N2O4. So yan yung system of what we call equilibrium. Okay, so if we're going to look at this equilibrium, okay, an example nga na usually nangyayari kapag meron kang physical equilibrium, it should happen in a closed system. Because if you're going to look at it, do it in an open system, what will happen? The water, when it evaporate to give you the water vapor, the water vapor will just disappear. Okay, the water vapor will not what we call accumulate unless it is in a closed system. Okay, so when you think that the water ceases to what we call the evaporate, so what is happening here is the water just in addition to being evaporating, it's also condensing at the same rate. Now, you can always achieve equilibrium at any point in time. Okay, so you can start with either this side, and then after some times it reached the equilibrium. So if you started with NO2, so siya lang yung make initial concentration. Okay, yung isa, the N2O4, wala siya at the beginning. But after some time, if you allow the system to establish equilibrium, you will see that The one that is present initially at a much greater amount will be less when it reaches the equilibrium, and the one that is less initially will have a greater concentration. And it will come a time that their concentration will not change. So that's when you establish the so-called equilibrium. You can also start when you have N2O4. So initially, yun yung may concentration. Yung product NO2, wala. But if you establish the equilibrium after some time, okay, what will happen is their concentration will remain the same. And during that time, you could say that the equilibrium was achieved. Okay? And you can start with any of them with initial concentration. Like you have some N2O4 and some NO2. So what will happen? Okay, one of them will increase in the concentration and one of them will decrease until such time equilibrium was established. Okay, so if you have this, you will have this so-called equilibrium. Now, you may ask yourself, what's really happening during this time? Okay, paano nila na-establish itong what we call equilibrium na to? So, when they try to determine some equation for this one, they use this so-called law of mass action. So when they look at the law of mass action, okay, this was formulated by Goldberg and Wadge, okay, they look at the ratio of the products over the products of the reactants. So they found out that it gives them a ratio that they assign as K. So you have to use the big K, okay? Because in the next module that you have, you're going to encounter a small K, which is what we call kinetics. So what they found out, okay, that if they're going to look at the ratio of the products over the products of the reactant at equilibrium, they will give a constant number. Okay, and the thing that they put there is they put a general equation determining the so-called equilibrium constant, A of A plus B of B producing C of C plus D of D, and using the law of mass action, it's just the products of the products over the products of the reactant. So C raised to the C times D over D over A raised to the A times B raised to the B. So that's the law of mass action. Now, if we're going to apply this concept to the example that we have here, so paano natin nalaman na pareho lang sila ng equilibrium? So if they determine, okay, so this is the initial concentration. So as you can see, NO2 is not there, only N2O4 is there. And then in another condition, N2O4 is not there, NO2 is there. But if you're going to look at the ratio of the concentration at equilibrium, okay, they gave you almost the same, if not close, K value. So that is the what we call concept of equilibrium. So question so far, okay lang magtanong from time to time. Because sometimes I tend to go for a pass. Okay? May tanong. Huwag kayong mahiya. May tanong?
None so far po.
Okay. Now, ano naman yung information na makukuha ninyo sa K? Okay? So, since the K is what we call the ratio of the products over the products of the reactant, it can give you some information. Okay? So, usually if K is greater than 1, you could say that there are what? More products compared to the reactants. Okay? So, ibig sabihin, mas malaki yung value ng numerator kaysa doon sa denominator. So, most likely your reaction will lie to the right. So what does it mean? It favors the forward reaction kasi mas maraming products compared to the reactants. Now, if K, okay, or if we're going to illustrate K is greater than 1, so we could say there are more products compared to the reactants. Now, if it's the other way around, when K is less than, we could say 1, so you could say the backward reaction is the one that is favored, okay? And there are more reactants compared to what we call the products. So that's the key information that you can get from the so-called K values. Okay? So yan yung we could say main info. It will tell you what we call which one is more or which direction is more favored or more favored. Okay? So question. Now, if you ask K equals to 1, so that means you have a system at equilibrium and you have the same amount of the products and the reactants. So, yun yung information na nakakapag what we call provide based on this. And this is helpful, okay? Because that means you can adjust the condition to the direction in which you want. Alin ba yung gusto mo? Yung nasa reactant side or nasa product side? So knowing the K, you can adjust the condition to favor to the direction of the material that you want. Okay? But the one that we have so far discussed is K in terms of Kc. Because when you say K in other books, they just put it as KQ. Okay? So, questions so far?
None naman po.
Okay. So, what we have discussed so far is homogeneous equilibrium. So this is where you have the same phase, or you just have one phase in a given system. Okay. Now, if you have the gas system in addition to Kc, okay, there's also another K. That's why I told you when I'm teaching Gen Chem, it's all about K. Okay. So this is the first K. So the next K that we have there, since we have a gas system, we can also express it in terms of partial pressure. So the expression of your equilibrium there is in terms of what we call Kp. And in most cases, okay, Kc is not the same as what we call Kp. Hindi sila pareho. But there are some instances where when Kc is equals to what we call Kp. Okay? So how do you relate, we could say, the C here with the P here? So what do you think the C here represent? C stands for what? Anyone? Ano yung letter C doon? Ano ibig sabihin nun? Or ano yung P? Dito tayo magsimula. P is what? Anyone? So your P there is in terms of pressure, partial pressure of the products over partial pressure of the reactants. Now, what is the C here? Is it what?
Concentration po, sir.
Okay, concentration. Because some would say it's constant, but the truth is you have to look at the bracket. So bracket usually means molarity or molar. Okay? Now, how do we relate your concentration with pressure? I'm not sure if you have the gas law.
So the more pressure, the more concentration, the more pressure.
Is it like that? Ano yung nagli-link sa concentration at pressure in terms of gas law? What gas law? Are you familiar with this? What do you call this? That's your ideal gas law. Now, how do we relate the two? Because you don't see the C there, right? Okay? The C there is when you divide both sides by volume. So what you have there, P is equals to NB over RT. So that's your C. Because what I'm trying to do now is how are we going to relate KC with KP? Ano yung equation nila? Okay? We can utilize, let's say, the general equation. So we have A of A reacting with B of B, producing C of C plus D of T. And usually they end up like this. But the question is, how did this equation obtain? Paano natin na-obtain itong relationship na to? Wherein Kp is equals to Kc times RT raised to the delta N. And the delta N here is described as the difference between the moles of the gaseous product minus the moles of the gaseous reactants. Okay? So if you're going to look at this, that's C plus D minus A plus B. But the question is how, okay, you're able to derive this relationship. So maybe I can give you a simple, we could say, reaction. So how about we have A of A producing B of B? Okay. So how are we going to put it in terms of Kp? So Kp here would be what? The partial pressure of, anyone? How are we going to do the expression here? So Kp is equals to the partial pressure of B raised to B over the partial pressure of A raised to A. We're just following this one here. Now, what we're going to do is we're going to replace the P with this expression here. Okay? So I will have I is as what? N of B over the volume times RT. And this is raised to the B. And then N of A over volume RT raised to the A. So what is common between the two expressions? You have RT on both sides, right? So I could simplify this further like N of B over B. Okay. And this one is N of A over B. So maybe I'll just put the RT there on these sides, and then I would have here B minus 8. So what is N over B over NA over B? That is your what? Isn't it this one? Which is your Kc. So you have the Kc times RT, okay, raised to the delta N, which is B minus 8. So yan yung nakuha ng relationship ng dalawa. Okay? Now the question, when do you think Kc is equals to Kp? Anyone? Anong kailangan mangyari para yung Kp ay maging katulad sa Kc? Anyone? The value of N should be equals to what? For this relationship to happen. Anyone wants to
Sir,
get?
hello sir. It should be equal on both sides po.
Sir,
Products
zero
and
po ba?
So delta N will be equals to what?
Zero po ba dapat, sir?
0. Because RT over 0 is equals to what? Is it 0?
One po, sir.
That's equals to 1. And when you have that value equals to 1, that's the time when Kp is equals to Kc. Remember that, especially kung multiple choice yung ano nyo, quiz. I have not written any quiz yet, but I have a lot of, we could say, material because I'm teaching this course in 2 other schools here in the US. Okay? So question on how Kp is related to Kc. Before we go to some we could say equilibrium expression. May tanong?
Sir, may tanong po ako.
Sure, sige.
Sir, yung homogeneous equilibrium po ba ay dapat gaseous to gaseous lang na magagamit?
Yeah, either gaseous to gaseous or aqueous to aqueous. As long as they have the same phase. Yung isa lang yung system nila, isa lang yung, we could say, phase nila. Darating tayo sa heterogeneous later on.
I mean, sir, pwede rin po ba kapag liquid to liquid? Ano?
Usually, ang term na ginagamit natin dun, yung aqueous. Liquid, we could say, is a
Okay.
constant. If we go on later sa ano natin, mga slides natin.
Eh, sir, nalilito lang po kasi ako kung hindi po siguro gaseous, baka hindi pwede magamit yung ideal gas law, ganun. Or
No,
pwede
no.
kahit
Pinasok lang natin yung ideal gas law kasi kapag gas ka, you can express equilibrium not only in terms of Kc but also in Kp. But if it's already other condition, you cannot use Kp.
Okay, sir. Thank you po.
Okay.
Yun lang po yung clarifications.
Okay.
Thank you po.
You can only use Kp kapag gas system ka. Pag nasa liquid ka na, it's only Kc. That's the what we call clarification there. Kaya in-introduce dito yung Kp. Because in terms of what we call the equilibrium system, you can express it in terms of what? Concentration. But if you have a gas system, you can also express it in terms of pressure. Because based on the gas law, merong relationship yung dalawa. Okay? But when you go on heterogeneous equilibrium, you will learn more. So another thing that's homogeneous equilibrium is if we have this one. So if we're going to look at this, how are we going to write the expression? So again, K is equals to what? The products over the reactants. And if you're going to follow the law of mass action here, all you need to do is write whatever you have in your products, divide it with the one that you have in the reactants. So most likely ito yung masusulat mo. Okay? But you have to take into consideration that one of them is what? A liquid. So if you have a liquid or a solid, usually their value can be what we call a constant. So what does it mean? They always remain the same. And the way that you're going to do is you incorporate that. If you do a cross multiplication with it compared to the other side there. So what happens is you're going to have a new K. Okay? So since it is a constant like that, you will have it like this. And this Kc that you have here, which is just equals to what? This one. Okay? Ang another term na gagamitin dyan is Ka. What do you think A stands for here? Anyone? Ito yung general expression natin sa equilibrium expression. But if we're going to look what's the exact equilibrium expression there, that's a Ka. Why? Anyone? Bakit we tinawag natin itong Kc na to na Ka? Because you have this one. What do you call this? That's the hydronium from the acid. Or you could just say, oh, you have an acetic acid here. So that's the equilibrium dissociation of an acid. Now, one thing that you need to remember, walang unit yung equilibrium. Okay? And you don't include liquid in the expression. So let's try to practice. Ito siguro yung mga question ninyo sa quiz tsaka dun sa ninyo exam or module quiz that they have. So write KC and if applicable KP for the following reaction. Sa A, pwede ba pareho? Or KC lang?
AC lang po, sir.
So, KC lang. Bago natin balikan. Sa B, pwede ba KC and KP or KC lang?
AC and KP po.
We can have KC and KP. You might ask, sir, paano natin malalaman kung pwede yung KP? Well, if you have a gaseous system, most likely, pwede yung KP. Okay? Sa C,
AC lang po.
okay? So sa C, KC lang. So masasagot nyo to? Masisiguro nyo sa akin na hindi magiging itlog yung score nyo?
Sana po.
I always tell my students, can you assure me that you will get this correct so that you will not get 0 in your quiz or in your exam? Because ito yung tinatawag natin, sure points nyo na tama. Okay? Now, the next thing that we're going to do, okay, we write the expression. So, whatever's the product, tapos kung meron siyang coefficient, erase mo yung product na yun to that number. So we could say the concentration of what? F minus times H3O plus over HF. Claro?
Yes po, sir.
So here, how do you express this? So you have NO2 squared over oxygen NO2. Right? Pasensya nyo na kung maingay yung anak ko. Naglalaro kasi doon eh. Yung kwarto niya yung pinakamalapit dito. Okay? Now, how about in KP? So instead na concentration ang ilagay natin, lagay natin yung partial pressure and then, not that one, just put NO2 and then squared over partial pressure ng oxygen times partial pressure ng NO squared. And then sa KC dito, again, hindi natin isasama yung liquid. So what we do is just the aqueous system over this one. Tanong. Question? May tanong?
None po.
Wala naman po.
Okay. So, ang next pero ihuhuli natin yung calculation. Gusto ko ngayon puro concept lang. Okay. So, babalikan natin to maybe next meeting. I just want to introduce you to the concept because I look at the materials, meron doon mga video about the calculation. Okay. I hope you watch that because the main thing that I do is just supplement it. Ang ano ko nga, sabi nila meron daw PowerPoint slides doon, but I want it to be in my own way on how I do this stuff, this thing, which I've been what we call using since I was teaching there before. Okay, so we have the HOMO. Now we go with the heterogeneous equilibrium. So anong pagkakaiba? You have more than one phase in the system, like this one. So how are we going to write the equilibrium expression? Because this might be the one that come out. Okay. So just like before, you only include either gas or aqueous system. If you have a solid, they are usually constant. If you just follow the law of mass action, it's just what? Products over reactants. But if you're going to look at the conditions that you have there, you could say, oh, solid to, solid to. So most likely they're constant. So even they're constant, you just incorporate them in the other side. So what's the Kc or the equilibrium expression for that is just equals to the CO2. Okay, the ruling that we have here, you may ask yourself, can we express it in terms of Kp? Yes, because in the Kc, it's all about the gas, even though you have what? Solid there, but the problem with the solid there are what? Constant. So kung gas lang siya, pwede mong i-express yung Kc in terms of Kp. Or you can express equilibrium expression as Kp. So the thing that you need to remember, the concentrations of solids and pure liquids are not included in the expression. Now, if ever this is a liquid, then you cannot express the Kp because there is a liquid system that you have there. Okay? Now, to picture out bakit ganito yung nangyari. Okay, we're going to look at the system. So how does the system looks like? So this is how the system looks like. So you have calcium carbonate there and calcium oxide. But with time, the only one that will change is what? CO2. Okay, and this change that you have in terms of CO2, you can measure it in terms of change in pressure. That's why you can express this equilibrium also in terms of Kp. So the PCO2, the pressure there of your CO2, it doesn't depend on the amount of CaO3 or CaO. Question? Before we go to another, we could say worksheet on how to write the equilibrium expression, but this time in a heterogeneous system or heterogeneous equilibrium like this one. Can we have Kc and Kp for the first one? What do you say?
Yes, sir.
We all know that we have Kc, right? The only question now is Kp available after that? I think here you have a gas, and then that's a solid. So that means you can. How about the second one? Can you have Kp in addition to Kc?
No, sir.
Okay, so it's only Kc. And how about the last one? Can we have Kp?
Yes.
In addition to Kc, can we have Kp here? So you have here a gas and you have here a liquid. Okay, so most likely what will happen here is, I think you only have Kc. So let's try to write the expression here. So Kc is equals to what here? Is this right? And Kp will just be the same thing. This one, Kc here, we have what? The concentration of Ag times chloride. And what you have here is another K that you will learn as we go on. And this one, you will have Kc, wherein you have 1 over Cl2 to the 6. And yes, you can have Kp. So you have here 1 over PCl2 to the 6. So kaya ba? Pag ganito yung mga tanong? Huwag kayong mahiya.
Sir, bakit hindi po nasali na yung yung reactant sa A?
Because anyone who wants to answer that question? Because it's a solid. So doon sa previous slide natin, sinabi natin dito, the concentrations of solids and pure liquids are not included in the expression for equilibrium constant.
Okay, sir. Thank you po.
Kaya?
Yes, sir.
Yung letter C, bakit siya fraction? Because ang definition natin ng Kc is what? Products over reactant. If you're going to write it following the law of mass action, ganito siya, di ba? But the thing is, anong kailangan natin gawin? Hindi siya pwedeng isama kasi sila ay constant. So nangyari, you will have 1 over Cl2 raised to the 6. Nasagot ko ba yung tanong? Kung bakit siya fraction? Kasi nandun siya sa nasa reactant side siya. And you're not going to write anything in the product because this is a liquid. And you're not going to include this one because that's a solid. So tanong pa. Nasagot ko pa yung tanong, German or Herman?
Yes po, sir.
Okay. Huwag kayong mahiya, okay? Libre magtanong. At kung kailangan nyo yung tulong ko, sabihin nyo lang. I think I'm going to give to you the Facebook, but just use it for chemistry related, okay? Because there's the based on experience, the best way I can help you is if you allow yourself to be helped by maintaining constant communication. Yun yung experience ko dito sa US. The difference that I have is sa atin dyan sa UPLB, you still doing an online. That's why they allow me to teach you. But here, which I just finished my semester in one of the university, the other university, I still have 2 weeks. But we do, in one university it's online, but in the other one, we do in person, limited in person. Yung lab, yung lecture, ganito din. Kaya sanay na ako na mag-isa lang ako nagsasalita. Tapos nagtatanong, andyan pa ba kayo? Are you there? Kasi hindi sila nababago. Okay? They usually remain the same as stated in the previous example that we have. Like this. And my suggestion is reviewing your material, and then I'm going to go on this thing. And if you have any question on the material that was shown to you, that's the time I can help you. Okay. So, ang ginagawa ko, tinitingnan ko lang kasi based doon sa ano kailangan isama. So, there are some topic that I might, what we call, jump in the slides that I have here. Like I told you, the calculation, we'll do it next time. Ay ako kasi first meeting natin, calculation agad. So this one, I'm not going to include this one. No, this one is, okay. So the next thing that I could say is just, I'm just going to discuss about this Q. So what we have right now is just Kc. So how is Q related to Kc? So Kc, that's the ratio of the products over the reactants at equilibrium. Q, on the other hand, that's the ratio of the products over the reactants at any time of the reaction. Usually you can look at it at the beginning of the reaction. Okay, so we could say QC and KC is the same in terms of the ratio of the products over the reactants. They are different because KC is when the system is at equilibrium, while QC is at any point of the reaction except equilibrium. Now, anong silbi nitong QC? So if you're going to know the value of QC with respect to KC, you can modify the condition, okay, to achieve the direction of the reaction that you want. So what does this mean? Anong ibig sabihin nito? So ano kapag mababa yung QC kaysa sa KC? So if QC is less than the KC, so what does it mean? Yun, ano ko na. Ano ko lang para malinis. Ito na yung last part, and then yung the chapter list next week na lang. So kapag ang QC is less than 2 KC, so that means the system should proceed from left to right to reach equilibrium. Okay? So para ma-reach mo yung equilibrium, the forward reaction must be favored. Now, if QC is equals to KC, then you have a system at equilibrium. So if you have a QC that is less than KC, okay, so that means the system must proceed in the backward reaction to reach what we call the equilibrium. Okay, so maybe I have to use some calculation here. Okay, but ano na natin yan next time. Because I just want at least right now for this what we call concept that we have. So the last one that we have for today, before we call it a day, is the Chateliers Principle. Saan natapos yung box game natin? Ano yung last number na meron tayo? If you recall. Is it 1327?
1327.
Okay. So what we're going to do? Mag-add tayo ng 20 item dito. So this becomes now what? 47. And then we continue the game. So the 13 that we have here is what? 7 will go here. Now this time, this is what? 47. So what is 1/4 of 47? Is it 12?
12.
So you lose 7, you gain 12. So that means this becomes 18. Oops. Right? And if this is 18, this is, you lose 12, you gain 7, this becomes 42. So what is 1/2 of 18?
9.
9. And then 1/4 of 42, can we say 11
10.
or 10? Ano yung number? 42 divided by 4. Wala akong calculator ngayon eh.
11 po.
So 11, right?
10.5.
10.5, so it's 11. Okay. That's why I want to make sure. So 9 here and then 11 here. So mawawala ka ng siyam, maano ka man. So this is what? 20. And this
20.
is 40. Right? So 1/2 of 20 is 10 and 1/4 of 40 is 10. So ano na mangyayari? Pareho na lang, na?
Yes.
And once again, yung question ko, yung kurentang item ba dito, pareho sa kurentang item dito? O yung 20 item dito sa box na to, pareho sa 20 items sa box na ito? The answer is yes or no?
No.
No. Unless at least 10 of them are different. So what do we have here? We applied this one, we added something, so the system tried to readjust itself. So ito yung stress na in-apply mo. And what happened? The system tried to readjust itself until you have a system at equilibrium. So remember, if we're going to look at this, so maybe ganito yung ano natin, right? Plot natin. Tapos nangyari, yung box P, nagkaroon ng 20. So, akyat agad ng 20 dito. And then after some time, what will happen? Okay? Nag-adjust siya. So, after some time, mag-aano na rin siya ulit. Magiging the same pa rin yung ano niya. Or maybe the best way to do is this one. So you change the concentration that you have here. So what will happen? Everything will adjust until the system reach equilibrium. So yun yung tinatawag na Le Chateliers Principle, named after Henry Le Chatelier. So if an external stress is applied to a system at equilibrium, the system adjusts itself in such a way that the stress is partially offset as the system reaches a new equilibrium position. So doon sa box game natin, okay, nagdagdag tayo ng 20. Yung system usually at equilibrium, di ba? Meron tayong ano dito, 7, and then here we have what? 7. And then what happened? You add 20. So ito yung stress na in-apply mo. But after some time, the system adjusts itself to establish a new equilibrium. So, ano tong mga stress na to? One of them we could say is the concentration. So, paano natin Ewan ko bakit naka-auto mode to. Paano natin makikita yung adjustment dito? So, try to imagine here what happened when you added something here. Which reaction is favored initially? The one going to box P or the one going to box R? So nagdagdag ka dito, nakita mo ito 7 pa rin. But when you added here, lumaki yung number na papunta doon. So we could say the backward reaction was favored. So we could say, whenever we add, okay, one of the species, the one that is favored is the one that will utilize that other species. So kapag nag-add ka sa product, ang magpe-favor ay yung backward reaction. Kapag nag-add ka sa reactant, ang magpe-favor ay yung forward reaction. Because what happened is the system try to relieve the added stress. So kung ano man yung nadagdagan, okay, kailangan siyang bawasan. Now, the question now that will be asked, so what happened kung ito naman ang binawasan mo? Let's say you decrease this one. Or you could say remove NH3. So the one that is favored is the reaction that will produce, okay, more NH3 to replace the one that was removed. Kapag ito yung binawasan mo, ang magpe-favor ay yung backward reaction. So this is how they do things in the industry. How do you think ammonia came into being? Anyone familiar with ammonia? I can tell you, you're going to be familiar. Pumunta kayo sa CR. Yung CR na hindi nalinisan ng ilang araw. Okay? The pungent smell there, that's your ammonia. Now, how do you do that thing? How do you produce more ammonia? So the way that they synthesize the what we call the Haber process is once ammonia is produced, they remove it right away. So if you're removing your product here, what will happen? Which reaction is favored? The forward or the backward reaction? Anyone? Kasi gano'n yung ginagawa nila sa industry eh. So para tuloy yung production ng ammonia, once na nag-produce siya, tanggalin agad siya. So ang magpa-favor doon, lagi yung forward reaction. So it keep producing NH3. Because if they don't do that, when more NH3 is produced, the backward reaction will favor. So yan yung, we could say, advantage ng the Chateliers Principle. You modify the system in such a way you favor the direction of the reaction that you want. So anytime you increase, it favors the direction that you're going to utilize the added materials. If you decrease it, it favors the reaction that will produce the replacement of this. Another thing we could say is changes in volume and pressure, and they go hand in hand. What gas law relate them? Anyone? Anong gas law yung nagre-relate sa pressure at sa volume?
Bernoulli po.
Huh? You familiar with this? Boyle's law? The higher the pressure, the lower the volume. So ano yung ano dito? Ano yung relationship nila? Pag in-increase mo yung volume, okay, nadi-decrease yung pressure. So pag in-increase mo yung pressure, ang pinipavor niya yung side na mas konti. Pag dinecrease mo yung pressure, mas mataas yung volume, mapipavor yung mas madami. Now, ang question now, paano pag magkapareho yung dami nila, walang effect yung pressure and volume? It will only have an effect if there's a difference in the number of sides in the products and the reactants. Okay? Bibilisan ko lang to pero babalikan natin to next meeting. And then we have what we call changes in temperature. Now, depende ito kung meron kang exo at endothermic. Are you familiar with the term? Exothermic at saka endothermic? The way I ask my student to remember that, that's X and that's N. So try to recall it as heat exit the system, heat enter the system. So they said here, when there's an increase in the temperature, since an exothermic, nandoon siya sa product, yung heat, okay? Increase of temperature. So in an exothermic reaction, the K would decrease. Why? Try to imagine that you have the heat in the product. If you increase the temperature, parang react what we call concentration. Ini-increase mo yung heat doon, okay? Nandoon yung heat sa reactant side. So ang magpe-favor ay yung backward. So ano mangyayari sa K? So product over reactant. So since nagpe-favor yung backward, mas maraming reactant doon, nababawasan yung K. Okay? But if it's an endothermic, you increase the temperature, nasa reactant side siya, so the one that is favored is the forward reaction. And then you have here, decrease the temperature, then you have K increases, and then you have K decreases. So maybe I'll just stop here because I just want to know how can we have a better way of open communication with one another. So question. May tanong kayo? So ito yung time na mag-aano tayo. Maybe before and after what we call the class.